Table 3. And it shows the frequency distribution, shows the volumes of sales in dollars, and the number of months a sales representative reached each sales level during the past 3 years. If this pattern continues, here's your forecasting, your predictions. What is the probability that the sales representative will sell between $75,000 and $124,999 next month? Now, is this a mutually exclusive table or not? Are these entries mutually exclusive? Yes, they can happen at the same time. Yes, a salesperson can make $124,000 and make $149,000 higher, but they're giving the highest one that they attained. So if they've attained a height of $130,000, that's where they fall. This table is mutually exclusive. So if we're looking for the values between $75,000 and $124,999, we're looking for these two blocks. And because they're mutually exclusive, we can come over here and add these together. So you're going to add these together, and because it's a probability is part over whole, you're going to put this over the bottom number, which I think is 36. Okay, so the probability of A plus the probability of B, and that's what will give us our OR statement. So, and then just put it in your calculator and give me 3 decimal places. Okay, because this table is mutually exclusive, it works really well. It also works very well for the complement case. Say I say, what is the probability, and that's not an add situation, that they don't make more than $175,000. You'd have to add all these up, right? Or you can do your complement condition. So these tables work nicely for your adds, for your multiplies, for your complement conditions. But for adding, this is a mutually exclusive table. We have no overlap there. For some odd reason, it's my right side of my board. Okay. We're going to jump down here for your blood donor one. Okay. Let's take a look at this exercise. Exercise 4. God bless you. God bless you. Okay. A blood bank catalogs the type of blood, including the positive or negative Rh factors. We did a tree like this. We did your 4 types. We did a tree. God bless you. And we came out with your 8 sample space items before. The number of donors who gave the blood, each blood type, is shown in the table. A donor is selected at random. Are these, well, it's kind of hard to ask this way. The blood types are mutually exclusive, and the Rh negatives and positives are mutually exclusive. You can't be a positive and a negative at the same time. You can't have more blood type at the different blood types either. But you can be an Rh positive and be one of the other bloods. So you have to be careful with this. Find the probability that a blood donor has type O or type A. We want the probability that this is happening. There's no given. This is your OR statement. So you decide, is there any overlap in a type O and a type A? No. So they're mutually exclusive. So you can add the probability of type O plus the probability of type A. So find the total for O, regardless of their Rh. Find the total, 184 over 409 plus, where's type A? 164 over 409, and all you have to do is add those. When you add fractions with the same denominator, just add the numerators. 348 over 409. And you can put this in your calculator. You can put this in your calculator at the same time as well. Put it in your calculator and give me 3 decimals.
0.851.
Good. It's 0.851. Remember where your probabilities are going to be 3 decimals. Okay? Now, the second part of this, I don't want to move it because I need to see the chart. The second part of it says, find the probability that the donor has type B or RH negative. Is that part of it mutually exclusive? No. So watch. Type B. Go like this. Type B. Type B is what? 45 over 409. RH negative. Here's your RH negative. The chart is really, really nice for this. What's the total for your RH negative? 65 over 409. Is there any part, thank you, is there any part of that, those two lines that overlap? Where? 8. So that's the part that you counted twice. You counted the 8 in this total. You counted the 8 in this total. So you've got to subtract out 8. Because these were not mutually exclusive. See the difference when they're mutually exclusive, when they're not? The table is the best way to do it, because once you hook the pieces up, you'll actually see where they intersect, where they overlap. So you add these two up, you get 110 minus 8, and then just give me a decimal out of it. You can go 3 decimals, it's probably easier. 249. Okay, so see the difference between when they overlap and when they don't. Okay, I want you to look at the bottom of page 160 and answer both of those problems. Find the probability that the donor is type B or type AB, and find the probability that the donor has O or RH positive. Same process that we did here. Bottom of 160. Left. No? Okay. Or not?
Yeah.
Yes, mutually exclusive. They can happen at the same time. And when you visualize row B, column B, and column AB, it's like your Venn diagram. Do they cross? No, they have nothing in common. They're mutually exclusive. So, God bless you. 45 over 409 plus 16 over 409 gives you 61 over 409, or what's your decimal? 150? 150? You got to round to 3 decimals. Now, the second part of this, I'm looking for a type O. I'm going to do it in green. Or an RH positive. Do they overlap? Yes. So are they mutually exclusive? No. So what's the probability of O? 184 over 409. And the probability of RH positive? 344 over 409. And what does that get you? 528 over. And what is that decimal? Oh, we forgot to subtract. Yes. Sorry, we forgot to subtract. Thank you. Was that Mariah or Olga? Very good. Wow. My board is still off. My mojo is still off here. So 344 over 409. What did we forget to subtract? 156 over 409. And in the last decimal, what does it come out to be? 372 over 409. And what decimal? 91. Oh, 910. Yes.
Mutually exclusive.
Mutually exclusive means they cannot happen at the same time. They're excluded from each other. They decided to mutually exclude each other. Yes. Because you see this where this overlap? You actually added 156 into this total. And then you added 156 into this total. So you added it twice. So you got to subtract one time. Do you ever go to the store and they ring up your items and they run one in twice? They just subtract it back out, right? So that it counts only once. So kind of the same thing. If we counted it twice, get one out of there. Another way to do this is add this, 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 and then add this and this. You can do it that way too. If you visualize it, you can do it that way too. Because it's greater than 409. Could the probability ever be greater than 1? No. So when you gave me the 1 point something, something has to be wrong. Your probabilities have to be between 0 and 1. And that's a very good point, Leslie. Very good point.
If it was like, let's say A, and like, negative, like the same kind of question like this, but it was just A, would you then subtract the 139 over 409? If it was the
So A and RH positive?
Yeah.
So you're going to go down the A, yes, you'd subtract the 139 wherever they overlap. Very good. Okay, now the last part. Okay, the last part is using that graph to find your probabilities. Okay, of selecting a draft pick. I thought I had the picture here, but it didn't come out, obviously. Okay, let's read this together. You're going to combine your rules that you know so far. Use the figure at the right to find the probability that a randomly selected draft pick is not a running back or a wide receiver. Now, read the top part. A breakdown of the position of how many players. How many players are they counting? 253. So all these positions add up to 253. They have 33 wide receivers, 26 offensive tackles. You see it? These are all their positions and their numbers. This adds up to 253. They want you to define events A and B. A draft pick is a running back. A draft pick is a wide receiver. So you want to find out if it's not a running back or a wide receiver. So the other way, there's two ways to do this. You can add up all the other things except wide receiver or running back. We'll just put it over the total, the 253. Or use the, what's it called? The complement. The complement. Use the sum of 253 and subtract wide receivers and subtract your running backs. Wouldn't that be simpler than adding up all the parts? Plus, it's kind of all over the chart, so you're kind of forced to make sure you count them all. So here's your complement condition. It's an or. I still have an or, but I have a complement condition. So look what they did. The probability of A or B, and they came up with that, and then they subtracted it from 1. Okay, so use your complement condition on these guys. All right, so you can absolutely do that as well. Are there any questions on the addition? The multiplication is the nicer one. When you're doing the and, you're doing your two things together, you're multiplying. When you're doing your or, you have to be careful of your mutually exclusive part. So